Hello everybody and welcome to chapter 7.2 of Advanced Functions. Today we're gonna start learning more about different techniques and also procedures to solve exponential equations. So first we're gonna talk about how to deal with equations that have different bases, and then we're gonna discuss how the quadratic formula can come into play when it comes to solving exponential equations. This chapter also focuses on questions revolving around exponential decay, which we've actually done in chapter 6.5. So if you don't remember how to do that, please go check out that video. It'll have the full, thorough explanation on how to do that. But now let's get started with our first part. So when we're solving an exponential equation, it is essential for us to understand these two concepts. The first one is that you can take the common logarithm of anything. So in this chapter, we will have to take the common logarithm of, for example, an exponential function to solve for it. Doing this does not interfere with the balance of the equation, as we are applying the same operation to both sides of an equation. We also have to know our power law, as it is extremely useful when it comes to solving for the variable, as it is usually, and it actually always is, part of the exponent. So now, knowing these two things, let's try to solve this equation. This equation here is actually coming from question 4.4D from your textbook. So luckily for you, I won't be assigning this one. So this is the equation we have here. 7 to the power of 2x plus 1 is equals to 4 to the power of x minus 2. So first what we're going to do is take the log of both sides. So we get log of 7 to the power of 2x plus 1 is equals to log of 4 to the power of x minus 2. Now, using the power law, we can move the exponents as a multiple onto the other side. And so we get this expression here. Let's actually use a pointer for it. There you go. Again, we'll learn how to do this. We'll learn how to prove the power law too. So this shouldn't be too complicated. Next, we need to remember our distributive property, which we learned a long time ago, maybe in like grade 9 or grade 10. And once we do that, we just distribute 2x to this and then 1. And so we get this expression here, and then x times this and negative 2 times this. So we get the equation, or this expression here. Now that we have these kinds of expressions, we can actually start collecting like terms. The like terms in this scenario are the terms that have a variable of x on one side and the no variable on the other side. This again will help us just isolate for the variable a whole lot easier. Next, I'd recommend, or what you should do, is actually factor out the x. And so what we get is x is equals to x times 2 log of 7 minus log of 4 is equals to negative log of 7 minus 2 log of 4. Now, solving for x, or again just isolating further for it, we just divide both sides by this expression here. And so we get x is equals to this really long expression. So depending on what your teacher says, for example, you may be asked to find an approximate value for x to the nearest 3 decimal points. You just take this extremely long equation and plug it into your calculator. Whatever value it gives you is the correct answer. You may also be asked to just find the exact value for x, which would be this value here, and so you would not have to go any further with that. Now, if you understand that, we can now move on to a second type of exponential equations, and that is something like this. When you first look at it, you need to understand we can't take the log of this function because we actually have, first of all, 3 terms, but we also have 2 terms of the same base, one of them being to the power of x, the other one being to the power of negative x, and so that could interfere with our solving. So I would not recommend going down the route we just did. What I'd recommend doing is actually making this into a quadratic. Well, how would you do that? It's actually really, really simple. Again, we identified that everything here has a base of 3, and this one is 3 to the power of x, and this is 3 to the power of negative x. What we can do to make this a quadratic is multiply everything by 3x. Because when we do that, we can actually expand, and we will get... Oh, this is written so poorly, sorry about that. We will get... There you go. 3x times 3x using the power rules you have learned before. We know when we are multiplying two exponents with the same base, we're actually just adding the values of the exponents. So x plus x is equals to 2x. Then 3 to the power of x times 1 is 3 to the power of x. And lastly, 3 to the power of negative x times 3x. Again, just adding the exponents, we would get negative x plus x, which is equals to 0. And so we get this equation here. Again, by looking at it, you can probably see where we're going with this. We need to understand that 3 to the power of 0, or anything to the power of 0, will equal to 1. And so our most simplified way of expressing this is this. 3 to the power of 2x plus 3 to the power of x plus 56. So now, just so we could perfectly see the quadratic equation we're dealing with, I'd like to rewrite everything in terms of 3x. So just factor out the 3x from here. So we get 3 to the power of x to the power of 2 plus 3x plus 56. As you can see, we have a square here. We have a value of 1 here, right? Because if anything to the power of 1, it just stays by itself. And then plus 56, we don't have a variable, which would mean this is to the power of 0. As you can see now, this is indeed a quadratic equation. So we can actually use the quadratic formula, which I've written over here, to solve for 3 to the power of x. You can do it in two ways. You could, for example, rewrite this again in terms of another variable so you can understand it easier, but that will require another 2 steps, which you might not have the time to do on a evaluation. So I'd recommend just writing it this format. Again, the only thing we're looking for is the coefficients of every term. So the coefficient of 3x to the power of 2, or 3 to the power of x to the power of 2 is 1. This is also 1. And then 56 is our constant term. So substituting those values into the equation, we get the following. Actually, sorry, this is not right. This should be -1. This should be negative, and this should be 1. There you go. And so the value of the brackets, either way, even if I wrote it wrong, we still know that 4 times 56 is way larger than 1 to the power of 2. For that reason, we have a negative value. This negative value this time will actually be even bigger, because again, I wrote it wrong. I'm really sorry about that. So 4 times 56 is equals to 224. 223 then. There you go. Again, we can't take the root of a negative number. We're not dealing with imaginary numbers within this unit. And so we have effectively proven that this equation here has no solutions. If we wanted to prove this using decimals, we also can do that. Again, just like any other equation out there, it is super easy to just get these numbers, plug them into decimals, and then see whether or not they have a solution. So I'm just gonna quickly type those in. 3 to the power of x. Okay, there you go. I'm gonna show you it now. As you can see here, it's black. Let's try to find where it is. As you can see, it's not even there. We can try. Let's see if everything's correct. Everything is correct. let's try to zoom out even more. There it is. So you could see this value over here can never touch 0. It's going into positive infinity, but it is never going to cross the x-axis. Again, we could also prove this by putting in the 0 there. Now, no matter how much we zoom out, we will never find that value because it does not exist. So that is how you would prove something using a graphing calculator. Now, still being on the subject of the quadratic formula in this context, we need to actually do a question where we do have a solution. So, for example, I chose this equation here, which is from question 11. Actually, is it from question 11? No, I think I made this one up myself. So from here, again, we're going to do the same strategy as we did last time. So finding out how we could express it as a quadratic. In this case, our base is 2 to the power of x. So we're going to multiply everything by 2 to the power of x. Doing that will produce this equation here. So again, 2 to the power of x times 2 to the power of x just equals 2 to the power of x. As you can see here. Then again, when we have a negative x times a plus an x, that's just equals to 0. So we get this term here. And now, since we talked about multiplying all sides by the same number, we have to multiply our right side, and so we get this value here. I simply just rewritten it so it looks more visually appealing. Now, we're gonna collect all of the terms and put them to one side. Because again, it's much easier to work with a 0 on one side than it is to work with -3 times 2 to the power of x. So bringing this value over, again, it just becomes positive now. So that was easy. Next, I want to organize the equation, again, just by expressing everything as 2 to the power of x, and also finally writing 2 to the power of 0 as 1. So doing those steps, we actually get this equation here. I've also put it in a standard form for a quadratic formula, just so we know what the coefficients are in this case. So with that being the case, we can now actually solve for 2x, 2 to the power of x, using the quadratic formula. So let's substitute all the values in, and then we could plug this into your calculator, and you should get 2 to the power of x is equals to these values here. Again, I don't recommend using or writing them in decimal form, because sometimes your teachers will be asking you to use the closest 3 decimal places, and you can only do that on your last step, because if you do it halfway through, you might mess up with the rounding somewhere, and so your final answer will be way off. So again, now that we have these 2 answers, we can try each one by itself and then solve for 2 to the power of x. So I took the left side, plugged it in here. Again, this is really easy. We've done this before. This is simply just using logarithms to solve for a question. Again, we could take the log of both sides, or we could have gotten like log of 2 of this value here is equals to x and use that equation there. But either way, whichever way you do it, you should get to this point over here, which is x is equals to log of -3 plus the square root of 33, all divided by 2. And then this whole value here is divided by log of 2. Plugging this into your calculator, you should get this approximate value here. So yay, we got an answer for our question. The second question, or the second part we have, is this value here. So 2 to the power of x is equals to -3 minus square root of 33 divided by 2. So you could definitely plug this into your calculator, like this value here, and then do these steps, but that'd be a huge waste of time for one reason only. we know that the value of -3 minus the square root of 33 will always produce a negative number. Again, we have negative minus something, so it'll become another negative value. However, when we're dealing with powers, remember that the range has to be positive. The range is that the function is greater than 0. So if it's less than 0, that cannot possibly happen for an exponential function. So this here is an extraneous root. Again, an extraneous root is essentially a root that would not be valid for the original equation. So you could try to solve for this value here, but you'd never find an x value, just because of the way the function behaves. And so, since we figured out that this is kind of useless and we can't do anything with it, our answer is right here. Again, we can plug this into Desmos and look at that. I think this is the answer over here. So let's zoom way back in now, you know, because we zoomed so far out last time. There it is, we're getting a blue line. Our blue line, we know, should be really, really small. There you go. It is approximately 0.4566. Is that what we got here? That's exactly what we got. So as you can see, the strategy works perfectly fine. And so this is exactly what you will have to do on your evaluations for this chapter. Now, the homework for today is the following. We have 6 questions here. Almost all of them, except for 2, are revolving around these examples I've just done. The other 2 are actually these kind of questions. Remember this format? We learned it in chapter 6.5. Again, we can go and look at those questions or learn it all over again, but I feel like that would be a complete waste of time as you have already studied these types of questions. So if you don't remember how to do them, I'll leave a link down below as well as the timestamp for the part of the video that you need to review. So hopefully that is enough. Otherwise, if you do have any questions, please leave a comment down below. I'll try to answer them as soon as possible. Also, if you have enjoyed this video, please leave a like. I know, asking for likes, not kind of cool, but it always just helps out. But yeah, either way, soon we'll start chapter 7.3, so that should be fun. And we're on our road to finishing the advanced functions course. I hope you've been enjoying this adventure so far, because I loved being your host for it. Either way, I'll see you next time. Bye bye!